Hardware. In this nugget, we address server hardware. That addresses not only Windows Server 2003 hardware, but it also really addresses other operating systems like Windows XP and Windows 2000. Most things we'll be looking at will be the same across the board. The current hardware that we have to work with is so much better than what we've had in the past. It makes plug-and-play work a lot better because of things like APIC, which is Advanced Programmable Interrupt Controller, as well as Interrupt Request Steering and Advanced Configuration Power Interface. All those things make plug-and-play work so much better. And we'll also take a look at drivers, which are the software interface between the operating system and the actual hardware itself. We'll look at how to install those, which is really a matter of installing the device and hopefully allowing plug-and-play to automatically install the driver. And then we'll take a look at what signed drivers are and what their advantages are. Also, we'll look at Device Manager, the various views that you can use within Device Manager, as well as how to report exactly the information you want from it. And we'll use some other tools also to look at exact hardware information that you might want to see. Then we'll look at how to configure your unsigned driver behavior, because these will, by nature, be less reliable or less stable than a signed driver. And you may or may not want them on your servers. Now, before we move on, I'd also like to point out that although my title is a trainer here with CBT Nuggets, I have to tell you, I want something a little bit more elaborate. Maybe a director of some kind, like the director of recreation on a cruise ship or something. Well, we're in technology, so how about we just start calling me the director of learning technology? How about that? Director of learning technology. In other words, you can just call me Dole. All right, I like trainer quite a lot. Let's go ahead and take a look at where hardware has come in the past few years. Well, I don't know how long you've been in computing. I've been in computing, over 20 years. And I'll have to tell you, in years past, and I guess when you get to my age, you can say in decades past, hardware installation was always a hassle. I mean, even in the days of DOS or Windows 3.1, you install a new modem, a new sound card, something like that, and you would always have these interrupt request conflicts or some other kind of a resource conflict. Or you'd have trouble with the drivers, and it really got to be a problem. Well, in Windows 95, we started with plug and play. And this is not a new invention with Microsoft. Really, it's a standard, an industry standard. It's just that Microsoft is the one that predominantly uses plug and play. However, we used to call plug and play in Windows 95 plug and pray because it hardly ever worked the way you would expect it to. So you had to, kill a few chickens and do a little dance to get the drivers to work right and for the device to install properly. Now, a lot of that is attributed to the fact that plug and play was in its infancy at that time, and the fact that back in those days, we really didn't have plug and play hardware the way we do now. I mean, the motherboards were not fully plug and play compliant. They might have a plug and play BIOS, but they were not what we call ACPI boards, which is Advanced Configuration Power Interface. Now, that sounds like it just has to do with power conservation or something like that. Well, it does have something to do with that, but it has a lot more to do also with hardware and with proper plug-and-play detection. Now, in this nugget, we're going to be taking a look at hardware, and specifically, we'll be working a lot with Device Manager. So let's go ahead and take a look at that. So to get to Device Manager, you can go to Start, Control Panel, down here to System, and that actually takes you to the System Properties, which are probably more commonly accessed by using the second method, which is to right-click my computer and choose Properties. And then there's a Hardware tab, which allows you to add hardware using a wizard. And then you can also configure driver signing. A signed driver is a driver that's been tested by Microsoft and then has been signed using certificates to verify that the driver has not been modified since it was originally tested. You can also go to Hardware Profiles, which allows you to configure a series of hardware devices in such a way for one configuration, and you can configure a different hardware profile for a different configuration. This may be commonly accessed or commonly used if you use laptops with docking stations, which have different hardware depending on whether they're docked or not. And then, of course, there's Device Manager here, which would open up Device Manager. Now, I more commonly will access Device Manager by using one of these other two methods. If I happen to be at a command line, then I can go to Start Run or Start Command Prompt. And if I happen to be at a command line, I can just do compmgmt.msc, and that'll open up Computer Management, which you can see allows us to access Device Manager. And then finally, probably the most common way to do this is to just right-click on my computer, then choose Manage, and that takes you to the Computer Management console here, and again, we have Device Manager. And then here we have devices that appear, and they're sorted by the type of device they are, whether they're floppy disks, hard disks, monitors, video cards, SCSI, sound, video, and game controllers. This might be a good place to actually to show you one of these cards. Here's my Creative Lab Sound Blaster card, for example. and we see that it is written with a Windows driver model driver, WDM is what that is. And that's just a simpler way for vendors to write drivers for Microsoft products, and Microsoft kind of writes a part of that for the vendor, so that all the vendor has to do is to write the driver up to a certain point, and Microsoft takes it the rest of the way under the Windows driver model. So if you want to see the properties of this, you can double-click on it or right-click on it here and choose Properties. It takes you to the same place right here. This tells us the device is working properly, where it appears on the bus. By the way, it says PCI slot 9. That's a little misleading because you probably might think of a slot as one of those narrow slots where you press a physical device down into it and then you screw it on in there with a retaining bracket. Well, this is a motherboard integrated device, so it actually appears in a slot that doesn't actually appear in that sense. It's an integrated device. Then we see a troubleshoot item here. Since it's a sound card and it recognizes it as a sound card, if I were having trouble with it, first of all, it could give me a device number in here. There are certain device codes that might appear in there. And then if I was having trouble with it, I could click the troubleshoot button, which opens the Help and Support Center with a sound troubleshooter, because as I mentioned before, it does detect that this is a sound device. And so you can give a little bit of help, or you can say, well, let's see, the sound appears to play, but I don't hear anything. And then you click on Next. And then it takes you through pretty much just a series of process of elimination, trying to determine, well, what the cause of the problem could be, giving you possible solutions. For example, is the sound even turned up? Is it turned on mute? Something like that. And if you determine that you're not turned on mute, then you say, no, there's still no sound coming from my computer, so we'll try something else. Click on Next. Or if you want to go back to where you started, you click on Start Over. So anyway, we'll click on Next. Is the cable connected? So that's one of the general rules of troubleshooting with hardware is always check the physical. Is it connected? How many times have we accidentally spent, a couple hours trying to troubleshoot something only to see that it wasn't plugged in or wasn't plugged in all the way? So you can say, no, I still cannot hear sound from my speakers. Click on Next. And this just goes on and on and on until eventually at the end it'll tell you that it's unable to provide any more options and you may need to contact your vendor or something like that. Now, I will have to say, let me close this now. I will have to say that if you're an experienced administrator, experienced with PC hardware, that might seem a little bit rudimentary to you to go through the troubleshooter because you say, oh, that stuff only an idiot would miss. But to be honest, a lot of times it'll remind you of stuff you might have otherwise forgotten. So if you've tried a few things, you can't get it to go, try this troubleshooter. It's really not a bad idea. Also, the troubleshooter is available if you go directly to the Help and Support Center. And if you go to this troubleshooting strategies link that we see here, then once you get into this, you see troubleshooters here, and you can see a list of troubleshooters for a variety of things, not only just for hardware, but a lot of other issues as well. What our interest is in right now is in the hardware item. So we'll just click on that. We'll specify which specific kind of device it is, sound card here, modem, USB device, and so forth. And then once you select one of these items and then click Next, then it takes you through all the same kinds of steps that I just showed you. Now, for troubleshooting purposes, you can also go to the device usage item down here, click down here, and disable a device, which might be handy if you suspect that it's conflicting with another device or is causing some other kind of a problem. Then you can disable it and see if the problem persists. Most of the time, of course, you'll just leave that enable. Now, if we go to Properties here, we'll see that some more information appears for this particular device. Just gives us more information about them. Some of them might be configurable, so if I click on this, for example, and choose Properties, then it might have a settings item, which is grayed out in this case. But in some sound cards, it might be available for you to make additional MIDI settings, for example. And this is unique to this particular sound card. Not all sound cards will have all of these available. This is kind of a vendor-specific item, actually, in this case, as well as the settings here also. So this might be relative just to the manufacturer that you select. And not all hardware devices will even have a Properties and or Settings tab, but they should have a Driver tab, what we have here. This tells us who provided the driver, Creative Technology Limited, or Creative Labs, as you might be more familiar with them, what the date is and what the version number is. This is kind of handy because you want to make sure that you've got the most up-to-date driver. Well, you can look at the vendor's website, see what they have. They might have a driver date of November of 2003 and a driver version of version 6.0. Then you can realize, oh, okay, I can go ahead and update this driver, maybe to add a feature or make it more stable or something like that. Now, speaking of stable, notice that the digital signer here is the Microsoft Windows Hardware Compatibility Publisher. That means that Microsoft has thoroughly tested this device and the driver, and they validate that it was stable at the time that they tested it. Once they see that it's stable, they use a certificate to sign the binary for these drivers, and then if anybody ever modifies these drivers, then the signature is no longer good, and you can tell that it's been tampered with. So we can be pretty much 100% confident that this driver is the valid, reliable version that Microsoft did test. Now, if you want to look at driver details, this can be really handy because you might want to uninstall a device and yet the files remain behind. And if you want to be able to get rid of the files themselves as well, which you feel might be causing problems, then you can click on the driver details. It tells you the actual file names. And in previous versions of Windows, boy, this could be really tough to track down all the exact file names. Notice that some of these are executables that are involved, or INI files for initialization files, which actually also assist in the setup process, DLLs, sys files, which are driver files, as well as DRV files, which of course are driver files. Another example of an executable would be the mixer utility for this, and this actually has a software interface that you use that allows you to interact with the drivers. So this gives you some more information about the files that are actually involved there. Then you can update the driver, and you just click Update Driver if you want to do that. It starts a handy little wizard here, and you can install the software automatically. And when you do that, if you click on Next, it'll look for any removable media like floppy disks, CD-ROMs, and it'll check to see if there are any INF files, which are information files, that are used to install drivers. It looks for those INF files on a floppy CD-ROM or other location with which it's familiar with, such as also a depository of drivers that appear on the hard disk. And then if there's nothing there, like it says here, that there's no better match, we just click on Back. Otherwise, if I did find a better one, we could choose to select from and then install it if you want. Also, you can install from a list or specified or specific location, and then when you click Next, you say, I don't want to search that floppy or CD-ROM, I want to go to this exact location, and you might have a driver in a location of your choosing. Now here also, it's just going to look for INF files that are there. If you want to be even more specific, you can say, don't just search for anything, I'm going to specifically choose what to install, and then you click on Next, and then it'll show all the compatible hardware available. And if none of these match, if you do have a disk, then you can click Have Disk here, and it doesn't really mean Have Disk as in floppy disk, which is what it defaults to here. You can still browse to anything, whether it's a network location or a local location, wherever you want to go there. And like I said before, it'll look for an INF file for you. Once you find what you need, you pretty much click Next and Finish, and it installs the driver for you. Now, if it turns out that, oops, I installed the driver for this device, and it turned out to be the driver for the wrong device. Now, that's increasingly hard to do because the INF files should be packaged in such a way that they will only allow you to install for the device for which they were designed. For which they were designed. But if it turns out to have been a mistake, you can say, whoops, that didn't work, click Roll Back Driver, and it'll go back to the previous version of the driver. Now, if you've updated the driver twice, it can't go back 2 times. It can only go back to whatever the previous version was, because when you update the driver, it automatically makes a backup of the existing driver so that you can do a rollback later on. And then if you choose Uninstall, it says Uninstall the driver, a little misleading because it does not uninstall the driver. It removes the driver from memory so that it's not active anymore, and it removes this Creative Labs device from Device Manager, but the driver files themselves will still be on the hard drive. Now, of course, remember that when you restart the computer, since this is a device that's integrated into the motherboard, it's still going to redetect that hardware, and it's going to still find the drivers that are on the hard drive and reinstall it. So unless you're pretty good with a soldering iron, you're still going to have that device on the motherboard that you have to deal with. If that's the case and it's really causing you a problem, you might just have to disable it like I showed you earlier. Also, I want to point out that users don't have to have special privileges to install drivers anymore. Because if the drivers are already on the hard drive, when they install a new device and plug and play detects it, they don't have to be an administrator for that. You only have to be an administrator now if you want to introduce a new driver that was not on the hard drive previously. And that's becoming increasingly hard to do because there's a whole bunch of drivers on a Windows XP 2000 or Server 2003 computer by default. And you'll see that if you go to Windows Explorer, where I am right now, and you go to the System directory, or the Windows directory in my case, oops, I went too far, and you go to the driver cache folder in i386. Did I just go? Driver cache, excuse me, i386. There's a driver.cab file which contains about 4,500 files, 71 megabytes of, guess what? Drivers. Yeah, all kinds of help files associated with them, DLLs that are also associated with them. These control things such as your FireWire bus, your USB, video, sound, all different kinds of things are within all these contents. And since these are already locally installed in driver.cab file, on the local machine by default. You don't have to be an administrator to install these. Now, also let me point out that if you have a service pack like we have for Windows 2000 or Windows XP, which we don't have for Windows 2003 at this time, at the time of this recording, then it will also include an SP1, SP2, SP3, so on and so forth, .cab file, and that includes any drivers that are new, improved, drivers that were not available at the time of the initial installation. So Microsoft tries to keep up to date with new products and improvements. And then finally, if we click on the Resources tab here, we see we have three types of resources, not all of which are present with every type of device. Some have only an I/O range, or an input-output range, which is actually a memory address. Some have an interrupt request setting, like this one, and some have a DMA, or direct memory access address as well. With the interrupt request, by the way, look at this, and you might see, ooh, 22? Hey, James, I thought we only had 16 interrupt requests, 0 through 15. Well, what do you know? We got more than that nowadays. There's two things that have really helped with interrupt requests, because that's been a big problem in the past, because that's normally the first thing you get a conflict with and the most difficult thing to resolve in previous legacy operating systems. And what has happened now is we have something called IRQ steering, and this allows multiple devices to use the same interrupt request. So that's one thing that helps. The other thing that helps is APIC, or Advanced Programmable Interrupt Controller, which now allows you to have, believe it or not, 256 interrupt requests. So I'm at 22 here. I've barely tapped into the available interrupt requests that we have. Now, if we did have a conflict, and this is extremely rare nowadays with the current hardware and the current operating systems that we have, but if I did have a problem, then it would show me a conflict down here. It's conflicting with a modem or some other device, and it would identify that device down here. And then I could manipulate one device or the other until I could change the settings. However, notice here that I also can't change the settings, because in order to do that, you have to deselect this checkbox, then select an item up here like the interrupt request, and then you would have to click Change Setting. Well, very seldomly can you do that nowadays with ACPI hardware and motherboards, because all that is so automated now, it just doesn't even let you change this. Now let me point out, a lot of administrators initially got a kind of a leery feeling about this because, hey, we're administrators, we like to be in control. But believe me, I've been working with this for years now, and I haven't had to mess with this change setting thing, I don't know, 3 or 4 years at least now, because this really does an excellent job, and especially with server hardware, which from your vendor is going to be very well pre-tested anyway. You probably never have to mess with this. Now, if you do, especially with a legacy device, maybe you had to introduce perhaps a modem rack into this server, and the modem rack has multiple ports so it can accept multiple modem connections. Well, a lot of those are kind of legacy devices, and for those legacy devices that are Windows 95 or older devices, that kind of thing, then you will have the ability to deselect this checkbox. At that point, you'll also have a settings-based on item up here, and you can choose from the drop-down list multiple settings that the vendor supplied that say, hey, if you don't work with the first setting, try the second one. If it doesn't work with the second one, try the third one, and so on and so forth. And it gives you some kind of pre-configured settings. If none of those work, then you can manually go to the settings and adjust them this way. Now, like I said, for ACPI machines, usually don't have the ability to deselect the Use Automatic Settings checkbox, but if I go to ports, your COM and your LPT ports, you can still deselect that setting for. So I'll double-click there and click on Resources, and then deselect this Use Automatic Settings. And then here you can see that I can choose from other basic configurations, 0 and 1 and 2 and whatever else I might need. And if I choose to do that, then I can select an interrupt request here, change the setting, and then this, of course, conflicts with COM2, so I'd have to scroll through this until I find something else that it wouldn't conflict with, like 7, or 11. There's another one. So I could choose one of those two interrupt requests if I needed to use an interrupt request. Now, by the way, with the port settings for an LPT port on an ACPI machine, normally you don't use an interrupt request anyway. That's the default behavior with ACPI. And with this radio button selected on the Port Settings tab, even if I were to select an interrupt request on the Resources tab back here, it wouldn't use it anyway. You can also select Try Not to Use an Interrupt. And with this, plug and play, when it scans this port, if it sees that this specific hardware port doesn't require an interrupt request, then it won't use it. If it does say that it needs an interrupt request in the scan, then of course it will use it. The reason why we have this never use and try not to use an interrupt request is so that we can free up interrupt requests for other devices if necessary. And then you can use an interrupt request assigned to the port. This is probably not going to be necessary unless you're working with really old hardware, an old BIOS, or old drivers that won't work properly unless they absolutely have an interrupt request assigned. This might also be the case with legacy applications that typically have to see an interrupt request assigned to that LPT port, and that's the only way they know to communicate with it. And then there's another item down here for enable legacy plug-and-play detection. I might talk about that a little bit more when we get into printers in this particular series. But if you have older printers, then it might be easier for them to be detected by plug-and-play if you select this checkbox. Now let's also look at something else important here in current discussions with hardware, and that is universal serial bus controllers, or USB controllers, which with version 2.0 right now is capable of up to 480 megabits per second. So it's pretty doggone fast. What we want to look at here is, first of all, USB root hubs. And these are integrated into the motherboard of this particular machine, and they appear just as ports external to that machine that I can plug in my devices to. Each one of these root hubs is important because it can support up to 127 devices. However, it has limited power. If I double-click on this and then click on power, you'll see that it's limited to only 500 milliamps per port. And here I'm using a human interface device compliant mouse. That's actually my trackball that I like to use. And a Plantronics USB audio adapter. That's my headset and microphone that I'm using to teach this course. And that gives me a total of 240 milliamps of power. Now, if I add too much other stuff on here, a camera, a scanner, any number of other things, especially if they are not self-powered, in other words, they don't have their own plug-in into an outlet where they have their own power supply and all of that. If they keep drawing power from this 500 milliamp port, then what's eventually going to happen is, as I get close to 500 milliamps or exceed that, then I'm going to have devices start to fall off and blink off, and they're not going to be available, and it's going to give you inconsistent results in inconsistent reliability for that hardware. That's a troubleshooting thing you might want to look for, is to see if there are too many non-powered devices on a specific USB port. Now, another thing you might want to look at is any of these host controllers for USB. So, for example, if I go to the USB 2.0 Universal Host Controller here and click on Advanced, I see that it's going to reserve a certain amount of bandwidth for the system. And this is the amount of bandwidth that is currently in use. And if I have any bandwidth-consuming devices, such as an external USB hard disk that has a lot of I/O on it, that can also appear here and tell me how much bandwidth it uses. And you can use that as well to determine whether or not a device is overloading the available bandwidth of your USB. Now then, we can also change the view of Device Manager by right-clicking and choosing View, and sometimes these other views can be very useful. For example, devices by type is the default. Devices by connection will allow me to see what dependencies each one of these devices has and how they're connected. For example, underneath the ACPI Uniprocessor PC, this is apparent to the ACPI compliant system, which is apparent to the actual PCI bus itself, where we'll see all the child devices attached to this PCI bus. So it might be useful if you just need to change the view of this to get a different perspective on things. And you can also go to View, Resources by Type or Connection. Now, both of these are very, very similar when you look at those. If I look at Resources by Type, then I can see under Interrupt Requests all of the interrupt requests that are in use, and I can see all the resources that are necessary there. I can also take a look at some of these other items, I/O, for example, and then DMA and so forth. Notice that, however, there's no parent-child relationship here, except for the parent being what kind of a resource it is. Likewise, if I go to memory, again, no parent-child relationships under here either if I want to see a hierarchy. The only real difference between these two views, resources by type and resources by connection, is that I do have a parent-child relationship. For example, with memory here now on the PCI bus, with this memory address, I see it as the parent of, and it is the part of the memory for, the AGP controller, which is the parent for the actual video controller itself. So you will see a parent-child relationship in some of these kinds of views here, again, if you go under View and Resources by Connection. Now then, having returned here to the default view, let's go ahead and take a look at another thing you can do, and that is to make a printout of all of this. This will give you pretty detailed information about what's on here. You do that by going to Action, and then you can go to Print. And then here we'll just click on Print, and I'll just click on Cancel for the time being. But you would just click on Print or Print to File, which might be useful also. And the reason for printing to File would be I might want to have on a file somewhere all of the resources that this particular server requires. And the resources that it will print out are how much free space is available on each disk, how many heads and cylinders each disk has. It gives you things like the interrupt requests that are in use, whether it's something's on an ISA bus or a PCI bus, all that kind of thing. It's very useful to see all the resource usage there. Now, another way to print things out is if you want to go to a specific category of devices. For example, if I wanted to go to my network adapters here, and I've got several different kinds of things there, including a FireWire network adapter, which is by default installed if you have FireWire on your bus, even though you might not be using it as a network card, so to speak, it still appears here. Now, what I can do now is to click on Action and Print, and now I can click on Selected Class or Device, and it'll print just the information for that selected class or device. You can also just do all devices and a system summary, whereas the default is just a system summary. This will give you quite a lot of pages. Make sure you got plenty of paper in the printer because that'll go for a good while. Now also, you might find it useful to view hidden devices, and the way we do that is to right-click on Device Manager, choose View, and then choose Show Hidden Devices. And first of all, let me explain a little bit about what devices are that are hidden devices. These would be any non-plug-and-play drivers, of which there are actually several, even though we're on a plug-and-play operating system. Windows Server 2003 all the way down to Windows 2000 and XP will still install non-plug-and-play devices or drivers for some very standard system equipment, such as the speaker that's at the front of the computer that usually issues the beep. Well, there's a beep driver for that example, and that's not a plug-and-play item. So anyway, that's the kind of devices that it will then show. There's also another kind of hidden device, and that is something called a non-present device. That's something that I previously had attached to the computer, but it's just not attached right now. Anyway, you can show these hidden devices by clicking on Show Hidden Devices. And then, of course, here would be my non-plug-and-play drivers. And then you see a variety of those that appear there, including the beep that I just mentioned a while ago. Now, it doesn't show here any devices that were previously installed that are missing. That's because you also have to set an environment variable in order for that to happen. And I opened up here the command prompt. By the way, you'll see me open that just real quick like that without going to the Start menu, because if you right-click on the command prompt on the Start menu and choose Properties, you'll see that there's a shortcut available. And I just entered in a shortcut so that if I press Control-Alt-M, it opens up the command prompt for me, and I'll do that for the remainder of our course. And then in our current discussion for showing non-present devices, what you'll simply do is to type in what you see here. This opens up the Device Manager console, and then a set command for this environment variable, set device manager show non-present devices equals 1. Now the other thing you could do is you could enter that in your system properties, and we won't go there for our time being, but if you want to go to the system properties and go to the advanced tab, you can enter this in as a permanent variable as well, and that way it will always show non-present devices anytime you open up Device Manager. For my purposes, I'm just going to go ahead and press enter, where it will open up Device Manager for me. Now, in this case, I'll go back up here to View again, and then I'll choose again Show Hidden Devices, and it would show me any devices that had been previously removed and that are not attached currently to this system. Now then, returning to our conventional Device Manager view here in Computer Management, let me also point out that you can connect to another computer. And the way you'll do that is by going up to the Computer Management up here where it says I'm connected locally right now. I'll just right-click there, choose Connect to another computer. This is very useful for any kind of remote administration, not just for Device Manager, but for any of these other things that you want to see back here if you want to look at the event viewer, for example, for that other computer. And I'll just type in the name of that computer, DC Nugget 3 in this case, and click OK. And of course, you saw there that you can also browse for it. Then under System Tools, I'll go click on Device Manager. Now, note that when you use Device Manager to look at another computer's hardware, it only looks at it in read-only view. I can't actually change any resources, and that's exactly what this message tells me. If I need to make any changes, I have to actually visit that computer, but at least I can view it here, and then I can also likewise go back up to Action, and once I select the computer here, and then print out its resources if I want to check out those kinds of things. Now, another excellent utility for looking at driver information is a command line utility called Driver Query. And you can look at all the various switches for this in the online help and support system. But you can use this to look at remote computers, local computers. You can export data into any kind of format such as table, list, or a very useful comma-separated value file. If you just do a driver query with no parameters at the end, then it just lists all the drivers on screen for you, telling you what the name of the driver is, what kind of hardware it controls, whether it's a kernel driver, which is most of your actual physical hardware is going to be a kernel driver, or whether it's a file system driver, which would be something, for example, such as the NTFS file system driver. And then it gives you the date like you see out there as well. Let me clear the screen and show us another example. Driver query, and then let's say in this case I want to do a /FO. I want to do a file format of a CSV file. I want it to be verbose information, and I can use a greater than symbol, which is not listed, by the way, in the online help, so just make note of that. And that's useful for most output kinds of commands where you want to output something. You can output that with a greater than symbol to a physical file, and I'll call this just drivers.c CSV, if I can spell right. And then it'll put in a drivers.csv file in my current directory, which is the C drive. Just press enter and pop, there it goes. Then what I can do is to look at that in Excel or something like that if I like. And what I like about that is when you look at this in something like Excel, you can see not only the name of the driver and a description of what it is, but it also shows you whether it's started or not, whether it starts at boot, whether it has to be started manually, whether it's started automatically, whether it's running or whether the driver is stopped, whether the driver is okay or not. It'll just give you an okay on there. It also tells you how much memory it uses and the actual physical location of that file. So very useful information from Driver Query. Now then, when it's time to add a hardware device, if Plug and Play doesn't detect it automatically and install the drivers for you, then you can also use the Add Hardware wizard, which is in Control Panel, and then it's just Add Hardware up here at the top. Then you'll see that if the hardware came with an installation CD, they recommend that you go ahead and install the hardware with that CD. This is particularly useful for something like a FireWire or USB device or various printers, especially multifunction printers. Because with most of those kinds of devices nowadays, you don't plug in the device and then let Plug and Play take over. You install the software and the drivers from a manufacturer's CD, and then you may have to restart the computer. Then you plug in the device and power it on, and at that point it will install properly. Otherwise, if you just allow Plug and Play to detect and install it, it may install some default Microsoft drivers, but you might lose some functionality, and you might not get, for example, with a multifunction printer, you might get basic print capability, but you don't get two-sided printing, or you don't get color printing, or some other fancy feature that the manufacturer's installation CD will include for you. In our case, I'll just go ahead and click Next, and I'm going to install a modem, which will be attached to a COM1 port. Modems are usually notorious for not being detectable through the COM1 port. They should still be Plug and Play capable, but they are often not. Then you specify whether it's already connected or not. I'll say yes, it's already connected. And then it sees that I have several devices already installed here, and I will simply say that it's not one of these already installed devices that I'm just trying to update, for example. I want to add a brand new hardware device, and then I could do a manual installation. If I choose Search and Install automatically, then it'll again look for removable media or any network installations that I choose, for example, network locations. I'll just manually select from a list, and I'm going to choose modems. I want to install a modem, and you see other types of devices that you can select from there. Then I'll just not detect my modem. I'll select it from a list because I don't physically have it attached here. I'm just going to give us the worst case scenario where it can't be detected through the port. So I'll go ahead and click Next here again. And then if I have a disk, I'll select Have Disk. Otherwise, I'll select whatever I've got here. Let's say it's a 5600 BPS modem, and then I'll go ahead and click on Next here, and then I'll attach it to or associate it with a selected port, such as COM1, and then Next. And then once that's finished, we just click on Finish, and now when I click on Device Manager by right-clicking on my computer and choosing Manage like we've done before, and then go to Device Manager, I see that indeed I have a standard 5600 baud per second modem installed. Now, you can look at these items in Device Manager, but you can also look at many of these things through other places in Control Panel by going to Control Panel, and I'm just going to right-click here and choose Open so that I can kind of hold it open and look at it a little bit better. Some of these will be installed by third-party vendors when you install their software. For example, the card tool is from GemSafe, and that allows me to log on with a smart card, which has a certificate on it. That way I don't have to use a username and password. Then we can also use the Persona item here, which is my headset function, which you're hearing me record through right now. Phone and modem options, which are relevant to the device I just installed, which was my modem. Also has my dialing rules so that I can specify my existing area code such that when I try to dial up a different area code, it knows that it's going to be long distance. And here are the modems that I installed earlier. By the way, the other modem, the number 2 there, I installed offline just so we can have another one to work with if we want. Now when I go to the properties of the modem, it's going to show me the exact same property sheet that I would have seen if I'd have gone to Device Manager, except that for modems, whether in Device Manager or in this interface, it gives you additional interface items such as the speaker volume, which is kind of a loud, screeching, irritating, nails on the blackboard kind of a noise. You can turn that off or turn it all the way up to high if you want it to sound like a 2-year-old that's not getting its way in the grocery store or something like that. You can also go to maximum port speed here. You can see the various speeds there as well. And then wait for dial tone before dialing. Just a quick tip here. In the United States, usually you'll want that so that you can get a successful connection. In many other countries, they don't have a dial tone. You just pick up the phone and there's no dial tone and you just start dialing. So you would clear that in some other countries. Diagnostics is very useful for querying the modem by clicking this button, and it'll test the modem to see whether it's sending and receiving signals properly. Advanced will be useful for extra initialization commands, which will help to set up the connection for custom configurations for other modems that you might need to connect to. And then the driver is the same thing that we've seen in Device Manager before. Well, Microsoft attributed in the past about 90% or more of their support calls to bad drivers. So they initiated something called a signed driver, and this is something that I talked about briefly a little while ago. This means that Microsoft has a vendor test their driver substantially to make sure that it passes certain tests using something called the HCT, or the Hardware Compatibility Test. And I think that's on version 12.0 at the time of this recording. Now, you won't probably, as an administrator, be using that, but your vendors will be, to see whether or not they can get their driver in compliance with Microsoft requirements and to make sure that it tests in a stable fashion. Once it does, they send a report to Microsoft, and once Microsoft does that, receive that report, they may also test it themselves if they do a full test, and then they will have to test the actual hardware itself that the vendor sends along with it. There's quite a process involved in that, and in fact, a lot of vendors don't actually go through the whole process because it is kind of time-intensive at times, and if they send any less than $10,000 worth of hardware for the testing process to Microsoft, Microsoft doesn't return it. I don't know what happens to all that hardware, but they don't return it. If it's $10,000 or more, then they don't return it unless the vendor sends written requests to have the equipment returned to them. So I don't know what happens to that hardware. There's probably a good black market in that somewhere. Anyway, there's also signed drivers with the Microsoft's private key. This relates to a public key infrastructure where a PKI will have a private key and a public key. Something that's signed with a private key can only be read by the public key. So that when you install the device driver that has been signed by Microsoft's private key, a Windows Server 2003 computer has pre-installed on it Microsoft's public key, and it will be able to determine that that signature has not been changed or that the driver has not been changed, and therefore you can be sure that this particular driver is a good driver and it's been thoroughly tested. Now, I mentioned a little earlier that users can install devices that have signed drivers. And when I say users can install devices, I mean domain users that don't have administrative privilege of any kind. Now, users can install the device if this driver is already on the hard drive and it's already signed. And if there's no interaction required, such as maybe resource allocation or something like that. Now, there's also a group policy which is slightly beyond our current scope, but there's a group policy that specifies whether or not you can install or load and unload device drivers. That does not relate to this kind of a thing where you can install devices and install the drivers along with them. That relates to whether or not a process, for example, can load and unload device drivers in memory, and it's a very highly secure function, so when you add that privilege, it could open up the door to a security vulnerability. So that neither applies to what we're talking about here, nor is it a recommended practice. Now let's go to the system properties where it talks a little bit more about signed drivers. We'll go to right-click on my computer again and choose properties here. And then when we go to hardware, we see this driver signing option. And by default, we see the middle choices selected to warn you every time you try to install an unsigned driver. Now only administrators can receive the warning and then choose to go ahead and install the driver anyway. So you have to be an administrator here anyhow. Now another thing you could do is just ignore it. That way you can just say, don't bother me with a little prompt, just go ahead and install it every time. Or you can block it, which is the safest way to go, and never install unsigned driver software. Probably can't do this on a lot of client machines like XP or 2000 machines, but on Windows Server 2003 servers where you really only want signed drivers anyway, might not be a bad idea to make this selection. And then you can also make this action the system default. What this really does is it allows the administrator to specify which one of these is the system default. If I select block and make that the system default, then someone else who comes in here cannot make it any weaker than that. If I choose it ignore and make that the system default, someone else could come in and make it a stronger setting, but you can never make it weaker than what the system default is here. Now you can also configure the driver signing options in a group policy. Now we haven't addressed group policy, and it's not even part of the topics for the 70-290. However, let me address real quickly what it is because it really permeates all of Windows and current Windows operating systems, including Windows 2000 XP and Server 2003. A policy would be something like a rule or a behavior that you configure for a given scope of management. A scope of management can be a site, which typically correlates with a physical location across a WAN, like Phoenix site or Tucson site or Los Angeles or something like that. A domain, which is a security boundary which our users use to log on and get their credentials, as well as our computers use to log on and get credentials. Or an organizational unit, which is an arbitrary group of users and or computers that you configure. And then you can configure a policy on, typically, an organizational unit. Now, to get to the policies, you'll click on Start, Administrative Tools, and then you'll go to Sites, Active Directory Sites and Services, so you can configure a policy on a site, but that rarely happens. Most of the time it'll be through Active Directory users and computers. And then also there's something else you can download from Microsoft called the Group Policy Management Console, which is kind of Microsoft's preferred way of managing policy now, but it's not installed by default, so I'll go to Active Directory users and computers for our current purposes. And then if you had a given organizational unit that you had created here, you could right-click on that. I'm just going to right-click here and choose a new organizational unit, and I'm just going to put in Phoenix as the organizational unit. Why? Because I live in Phoenix, and because I love Phoenix, and because, hey, I'm the teacher, I get to create what I want, right? So I'm creating Phoenix here, and then I would put users and computers, for example, in this organizational unit, or groups. Now I'll right-click here and choose to go to its properties. And when I go to Properties, there's a Group Policy tab where I can create a new policy. And I'll just call this Phoenix Policy. Then I would click on Edit. Now, that's more than we really have for our current list of objectives with this topic. However, like I said, you have to know how to at least get here because there's too much involved in Windows. Now, the next thing I want to do is to show you how you can configure the driver signing options in Group Policy. Now once we're here, the way to configure those driver signing options is to go into the Windows settings, and then you'll go down to Security Settings, and you'll go to Local Policies, and then finally Security Options. Once you're down here, you can go down to the Unsigned Driver Installation Behavior under Devices right here. So you'll simply double-click on this, and then you define the policy setting. Now, since I'm doing this on the Phoenix OU, any computers that I put, since I'm under computer configuration over here, any computers that I put in the Phoenix OU will be subject to whatever I specify here, regardless of whether someone tries to manually override that in the system properties on the local server. So I'll define the policy setting, and I can say silently succeed, which is the same as ignore. I don't know why they can't use the same wording in the actual interface for system properties as they do in the policy here. I guess that Microsoft, the right hand, didn't know what the left hand was doing. Anyway, we can also warn but allow installation, which is the same as just the warn setting, and then do not allow installation, which is the same as the block setting. So if you want to be more restrictive, you can click on this item here, and then click OK. And then now, nobody could install unsigned drivers on anything under the scope of management for Phoenix. Now you might also want to see exactly which drivers are signed on your system. So you can do that by going to the Start menu and going to Start, All Programs, Accessories, System Tools, and then finally System Information. You can also just go to a command prompt and type WinMSD like that from a command line, and it opens up the same thing that we just saw on the Start menu. And then the system information is really a wealth of information about the entire system, and it's pretty handy to go through and just kind of check out the various things that are there, but what we're interested in here for drivers is under Software Environment and then Signed Drivers, and this will take a little while to refresh. Once it does, it gives us verbose information about all the drivers that we have installed here, whether or not they're legacy class drivers, which would be the non-plug-and-play drivers, which are nevertheless signed, what the driver version is, what the date for it is, who manufactured it, the INF that was actually used to install it, for example, and so forth. This also gives you the device ID, which will help you to locate it in the registry, because in the registry, each one of these devices has a device ID that you can look at under HKey Local Machine if necessary for very detailed and difficult, by the way, troubleshooting purposes. In this nugget, we took a look at server hardware, and particularly at the current hardware that we have, which is a great advancement from what we had when Windows 95 first came out, where plug-and-play barely worked. Now plug-and-play works great through ACPI, Advanced Configuration Power Interface. We also have advanced programmable interrupt controllers and IRQ steering to give us great resources for interrupt requests, and we seldom, if ever, will ever run out of those again. Then we took a look at drivers, and of course when you install a device, you also have to install a driver for that device. Now remember that if you're a generic user, a domain user, you can install a device as long as the driver is signed and already on the hard drive and as long as it doesn't require any configuration on your part. Then we also took a look at what a signed driver is and how important they are and how they're tested. We looked at Device Manager and the various views that you can use, as well as how to configure devices from within Device Manager. And we also looked at how to configure certain kinds of devices, possibly from Control Panel, depending on the type of device it is. Then we looked at unsigned driver behavior. This is critical because especially on a server, not so much your XP machines, but especially on a server, you probably don't want to ever install any devices that are not signed, so you can guarantee yourself maximum stability and uptime. Well, as your Director of Learning Technology, let me say that I hope this has been informative for you, and I'd like to thank you for viewing.